So the Ascent Tower is a 410,000 square foot tower, 17 stories of mass timber over 6 stories of concrete, parking structure below and residential units above, about 231 residential units within those 17 mass timber levels in the Easttown neighborhood of Milwaukee, Wisconsin. When it comes to the design, we're really looking at making sure that we are designing a structure such that every dollar we spent is providing value to the end user. And so that means figuring out which columns and beams need to be exposed and maybe which columns and beams can be encapsulated and therefore smaller members because they don't need to have sacrificial char dimension and significant upsizing, which adds cost. I think ultimately the goal is to design the building in the virtual world in this 3D model so that we can prefabricate as many of the building components as possible. That includes timber structure and also plumbing trees and ductwork. There are prefabrication opportunities there so that the construction process on site really becomes more of an assembly of components rather than a lot of cutting and there's less waste on site. There's potentially minimal or zero waste because all of the components are coming to the site exactly cut to size and labeled for their specific location in the building. Well, right now, one of the biggest barriers is that the construction, the prefabrication, the manufacture of a mass timber structure is 100% reliant on a fabrication level 3D model that is not a contract document, at least not with the architect and engineer. And so our contract documents are really 2D documents, right? We're working in a 2D setting, and while we might be working on a model in parallel, it's not something that any of the designers are contractually obligated, to perfect. So I think that's one major hurdle that we'll eventually overcome. Another obstacle there is that buildings are still permitted in 2D, and so how do we move to this 3D environment when will our building officials be comfortable with that, and how do we get everyone comfortable with that? I think there are multiple aspects of mass timber construction that will require adaptation in our educational curriculum. One is just an understanding of the material science. Understanding wood and its properties is critical to successful construction detailing. Understanding how wood behaves when it gets wet. These are all really important kind of fundamentals to have when delving into mass timber design. I think there's a lack of timber engineers in the country, and so a lot of the timber engineers who are designing these buildings are coming from Europe. They're coming from Canada, where there is a greater emphasis or focus on timber in engineering school. And I think it's just going to meet a market demand. Eventually it will start to shift as this becomes more mainstream.